for the sake of those who are not here. Okay, yeah. We're going to cover algebra, and under algebra, the first topic that we're going to do is solve for x. We must be able to know how to solve for x, and then the second is solve for x and y, which we call this simultaneous. So simultaneous equation. And then the topic number 3 is going to simplify. So we must know how to simplify. So this is what constitutes a algebra. So even though on this solve for x, we have 3 different branches, which we must be very careful about. So the first solve for x we will come across is when we are using what is called the factorization. So we will solve for x by using the method of factorization. And then the second method that we're going to use in order to solve for x is what is called a quadratic formula. We must apply the quadratic formula in order to find the value of x. And then the last one, we are going to use either the table or the graph methods. So now, the table and the graph methods, we use them to solve what is called the inequality. We use them to solve what is called the inequality. So now it means under solve for x, there are 3 kinds of solve for x. The one which you can factorize, and then the one which you can only solve by quadratic formula. And then the last one is the one which we can only solve by either the table or the graph methods. And these kind of questions is when we are dealing with the inequality. And then number 2, we have simultaneous, of which on simultaneous would be solving for x and the value of y. And then the last one is for simplifying. Simplifying is when we are implementing the exponential rule. We must know very well about the exponential rule in this case. So this constitutes the very first chapter, which is very, very important. So it constitutes the very first chapter, which is called algebra. And this chapter of algebra is going to have about 25 marks in your final examination. So you must make sure that these 25 marks, you get them all, because there's nothing difficult under this topic here. So you must be able to score all the 25 marks under that topic. So by today, I would like to take you through some questions. Can you see everything which I'm writing on the board?
Yes, sir.
All right, so I'm going to take you through some questions that involve these 3 subsections under algebra. So we will start with the first one, of which is solve for x in this case. So we're going to use factorization. The first one will be for factorization, quadratic, and table. And when they ask, they don't select here. So they will bring all questions under solve for x and all questions under simultaneous, all questions under simplify. So there's no question paper which you will find without having all these topics which are on the board. Let's start with the very first one, of which is factorization is solve for x by factorization. So I'm taking this from the previous question paper. So the first one is when we are having x into 2x plus 1 equal to 0. And this question requires us to solve for x. It requires us to solve for x, but this is very simple. Let me choose another one beside that, because I think it's a very, very simple question which we don't have to spend much time on. Let me check another previous question paper for us to avoid spending much time on a very simplest question. All right, I'm I'm searching for other question papers we can use beside this one, because this one is a very simple question. All right, I will use for November 2020 examination. November 2020. So it's for last year. All right. So now the first question here, it requires us to solve for x. We want to solve for x on this first question of 1.1.1. So how can we solve for x on this question given here? Let's see which question we're going to do in this case. All right, each card loader, I want to ask you something. And uhomola examination nga June kana nga December nga November.
Nga December.
Nga December. Yeah, because I will want to make sure I groom you to an extent that you don't have any problem when you write your final exam. So that I will make sure. So before you write an examination, I must be sure that when you sit for examination, you are going to write and pass mathematics. Oscar in previous year, Musa Chita grade 12.
No, I'm now 45.
Okay, no. This time around, you must score above 60. So our benchmark is 60 going upwards. So now, let's do this first question here, where we are given x squared minus 6x equal to 0. And we are required to solve for x on this question. So how do we solve for x on that question? So we have to use the first method of factorization. So in order for us to factorize in this case, we can just take out x as the common factor. So we don't have to use two brackets because we have only two terms. And on these two terms, we have x, which is a common factor. So in this situation, we just have to take x as the common factor. And when we take out x as the common factor, it means here we're going to be left with x. And when we take x as the common factor, we're going to be left with 6 there. So, and this must be equal to 0. At all times, when you do this simplification, we must make sure on the right-hand side we have a 0. So otherwise, if it is not 0, then it cannot be factorized. So, or if maybe there's another number, it means that number we must take it to the left-hand side and then we factorize so that on the right-hand side we have a 0. So after taking out the common factor, we're going to have this expression here wherein x is going to be equal to 0 or x minus 6, it will be equal to 0. So we make x the simple formula, so it means x is going to be equal to 6. So that's the very first question which we must be able to do. And then the second question here, we are having x squared plus 10x plus 8 equal to 0. Whenever you come across a question which says correct to 2 decimal places, that statement, it simply tells you that you don't have to factorize, but you have to use what? Quadratic formula. So take note of this. If you check on 2020 question paper, question number 1.1.2, we are given an equation and it says correct to 2 decimal places. So whenever you see that statement which say correct to 2 decimal places, it means you must go for quadratic formula. You must go for quadratic formula. Don't look for factorization or any other method. You must go directly to the quadratic formula. So I hope that statement is clear. So now the quadratic formula, when we apply it to this question, So it means we're going to have x, which is equal to negative b plus or minus a root of b squared minus 4ac, all divided by 2. Make sure you divide from negative b. Some they divide from here. It will not be correct if we divide from here. So we must divide from negative b. So then now we're going to have x, which is equal to, we identify the value of a, of b, and of c. So the value of a is the coefficient of x squared, and the value of b is the coefficient of x, which is 10. And then the c is a constant, which in this case is what? Is 8. Let me write that. A is equal to 1, b is equal to 10, and c is equal to 8. So you need to substitute this information into our formula. So it means we're going to have x, which is equal to negative 10 plus or minus a root of 10 squared minus 4 into 1 into 8. And all this is divided by 2 into 1. I hope we are together up to that point. Is that so?
Yes, sir.
All right. After having that, we will have to simplify what we are given inside the root. So, and the simplification is going to give us negative 10 plus or minus root of. So you can just put that into your calculator. You are going to obtain 100 minus 8 into 4, which is 64. And all this must be divided by 2. So now, here we have a positive and a negative sign. If we have positive and negative sign, it means we can separate these two, and we have x equal to negative 10. So you take with the positive sign, and we have root of 26 divided by 2. And the other answer is going to be x equal to negative 10. Instead of taking the positive sign here, we now take the negative sign. So it's negative root of 64, all divided by 2. So now we can get the final answer for this value of x here and the value of x there. So that you can only get by using your calculator. So we're going to have negative 10 plus a root of 26, which it must be divided by 2. So that simply means that we're going to have x, which is equal to negative 2.45. And then on the other side, we're going to have, so we just change the sign. Instead of having the positive there, we have the negative. And when we have the negative, we're going to have x, which is equal to 7.55. And that's all. So this is how we get the value of x by using the quadratic formula, of which the quadratic formula we use in any situation where they say correct to decimal places. So I hope that question is clear. Is that so?
Yes.
All right. Then now we go to the next question. So the next question is the inequality. This is the very important question which many people, they usually skip. But from now going forward, you no longer have to skip this question, because I'm going to explain to you in detail of how we deal with this situation. So we are having 1 minus x and x plus 2, which is less than 0. We are fortunate that in this case, this question is already factorized. It's already factorized. So in some cases, we may not come across a question which is already factorized. So we must we no longer have to spend much time on factorization. We just have to apply either a table method or a graph method. So you can choose the method you prefer. But myself, I usually say you need to understand the two methods, the graph method and the table method. That's why in this scenario, I'm going to do 2 methods, and then from there, you will learn until you get the one you prefer most. So let's start with the table method, where we are required to find what is called the critical points first. We are required to find what is called the critical points. So the critical points we get when we let the inequality to be 0. So we are having an inequality of less than in this case. So we let that to be equal to 0 like that. In other words, we just remove this inequality and we have a 0. That's the first thing in order for us to obtain what? The critical points. So now, the first bracket you equate with 0 and. In this case, we don't say or, we say and. X plus 2, we equate it with 0. and we make x the sum of the formula by taking this negative x to the other side. So it means we're going to have x which is equal to 1, and then on the other side we have x which is equal to -2. So we now have two critical points. We now have two critical points. So then now we have to go back and check the kind of inequality we have here. Is this inequality strictly less than 0, or it's less or equal to 0? So if we check together here, this is strictly less than 0. The one which is not strictly less than 0 is when we are having less or equal to. So this is not strictly less than 0, but the one we have here is strictly less than 0. So if we have the one which is strictly less than 0, this is how we're going to create a table, even though it will be similar with this one. But let me explain this one is strictly less than 0. All right, before that, let's test the inequality here. We're going to have inequality for less, inequality for greater. And we need to test all of them on this value of. All right, I'm back. My network dropped me, but let's continue. So I was saying, in this case, we have two critical points. So we have critical points of x equal to 1 and a critical point of x equal to -2. Yes.
Yeah, I cannot see the screen.
Are you with me now?
No.
Or you can see the screen?
Yes.
All right.
I can see it now.
All right, it's okay. So now we have two critical points in this case, a critical point of x equal to 1 and a critical point of x equal to -2. So now on these two critical points, we need to test the two inequality. Is the inequality for less than sign and the inequality for greater than sign. So let's test all of them. Yeah, I think my network is misbehaving because of load shedding. Can you see the whiteboard now?
Yes, I can.
All right. So I was explaining here that we have two critical points, of which in these two critical points, we must test the two inequalities. So the inequality of less than sign and the inequality of greater than sign. So now when we test the inequality on these critical points, so it means we're going to have x less than 1, and again we have x greater than 1. And we do the same on this other critical point. It means we're going to have x less than -2 and x greater than -2. So we tested the two inequality. So we replace equal sign by less than sign, and we replace equal sign by greater than sign. And we do the same this side. We replace equal sign by less than and also by greater than sign. Is this clear before we go to the table?
Yes, sir.
All right. So now on the table, it's just a matter of arranging these numbers from the smallest to the biggest. So we check all these three numbers here. So x equal to 1, x less than 1, x greater than 1. And again, here is x equal to -2, x less than -2, x greater than -2. So we arrange them from the smallest and then to the highest. Can you tell me the smallest value between these 6 values we are given here?
Smallest values.
Yes, the smallest value from these 6 values here. So let me.
-2.
Yes, it's x less than -2, right? And then
yes. And x less than 1.
Yes. We still have this one. So we have x equal to -2, and then we have x greater than 1. So we have x greater than -2 as the next value. But there's something very interesting on this one, because this is the middle value. So it coincides with other value we have here. So we can write them together. We write this highest value on this set together with the smallest value on that set. So how do we do that? So we say x must be less than the lowest value here. What is the lowest value? Is this one, x less than 1. We write it there, and then again here we write the highest value, which is -2. So we combine and write them together. So is the highest value here and the smallest value there. We combine them together and we write them in. My network is misbehaving. So I swapped the networks now, but this one we are using, normally it will be connecting, but you may not be able to, it will be shining. So if it is shining, let me know before I proceed. Can you be able to see what we have on the whiteboard?
Yes, I can, sir.
All right. So I was explaining about this important inequality here. So it takes the highest and the lowest in this case. So it combines them together. So we have x greater than -2, which is this one, and x less than 1, which is the smallest here. So it combines them together. And then after having that, we are going to have the next one, which is x equal to 1. And then after that, we have the last one, which is x greater than 1. So this step is what many people, they consider it as the most difficult step, of which I'll want to emphasize again. Because once you understand this step here, any other thing may not be difficult for you, because they are simple to understand. So let me explain this part again, that we take from the lowest value to the highest value. So the smallest value in this case is x less than -2, and the highest value is x greater than 1. So it means we are starting from the smallest. We can say this is value number 1, and then this is value number 2, and this is value number 3, and this is value number 4, and this is value number 5, and then that is value number 6. So I arranged them according to the order: the smallest, second smallest, third smallest, fourth, fifth, and then the last one is x greater than 1. Is that clear?
Yes.
Yes. So this one, we write it as it is. The first value, which is the smallest from all these, is x less than -2. And then the second smallest is x equal to -2. We write it as it is. So, but these ones, because they are now, it's like a intersection. So we write them together at all time. These number 3 and number 4, we write them together in this way. So we say x is greater than -2 and x less than 1, which represented this. So we write them together at all time. And then after having this, we have x equal to 1, which is this one. And then x greater than 1, which is the last one then. So after you have this, I can tell you what is left is very simple. So we take the first bracket here, which is 1 minus x, we write it there. So it's going to be our first block. That will be our first block. And then the second block is the second bracket, which is x plus 2. So it's x plus 2. And then the last block is the product of this. So it means you're just going to write what you are given up there, which is 1 minus x and x plus 2. It's what you are given up here. You write them in a form of a product. So this is called a sign table. And that simply means that we're going to write signs inside these blocks. We're going to write signs inside the block. How are we going to get these signs? So we check on the first block, we have x less than -2. So we must choose any number which is less than -2. Can you tell me any number which is less than -2?
Less than -2.
Yes.
-1. And -3.
-3.
Going downwards.
Definitely. So -3 is the one we're going to use in this case. We substitute -3 here where we have x. So if we substitute -3 where we have x, this expression, it will be equal to what? If we substitute -3 on that first expression,
4.
it's 4. So it's a positive 4. We are just looking for the sign in that case. So it means if you substitute any value which is less than -2, starting from -3 going downwards, you're going to get a what? A positive sign. So that is clear, eh?
Okay. Yes.
And then we substitute -3 again here where we have x. If we substitute -3, we'll have -3 plus 2, which is -1, right?
Yes.
So we are interested to the sign only. So we write negative. So on the other block, we're going to do it at later stage. Let's now focus here on the second one. So we substitute x equal to, it's an equal sign here. So we substitute this as it is. So when we substitute -2, we'll have we'll have 1 minus into -2, which is +3, right?
Yes.
So we're going to have a positive like that. And then we substitute -2 here, where we'll be having -2 plus 2, which is a 0. And then we substitute.
Also, can 0 ringwala 0 fedi arangwala uri positive or negative.
Yeah, because 0 is a neutral number. We can't tell if it is positive and if it is negative.
Okay.
Yeah. So, and then on this other one, we take any number in between -2 and 1. Can you tell me that number which is between -2 and 1?
It's -1, 0.
Yes, -1. We substitute -1 here. So it means we're going to have 1 minus into -1, which is +2, right?
Yes.
So then we have a positive there. And then we substitute that -1 again here. So it means we're going to have -1 plus 2. And that will be what? It will be a positive sign. And then we substitute a 1. If we substitute 1 here, it's 1 minus 1, which is 0. Therefore, we're going to have a 0 there. And then we substitute 1 down here, it's 1 plus 2. So it means we're going to have what? A positive. And then we substitute any number greater than 1, which we can say is 2. If we substitute 2 here, which sign are we going to get on this block?
Negative.
We're going to have a negative. And then if we substitute 2, what are we going to get if we substitute 3? Is it positive? We're going to have a positive, right? So after getting that, on the last one, we just need to find the product of these two. We're going to multiply these two. So it's this times that. Positive times negative, it gives what? A negative. Positive times 0 will give a 0. And then positive, it will give a positive. 0 and positive, it's a 0. Negative and positive is going to be a negative. Is there anything you did not understand from what I explained from where we started up to here?
No, sir.
All right. So after having that, we are just left with one statement, of which is for concluding. So the conclusion, it comes from this inequality here. So if it is less than, so it means we must go and look for a block where we are having the negatives. If it was a greater than, it means we're going to look for a block where we have the positives. So, but here, because it's less than, we will be looking for this block where we have the negative and that block where we have the negative. That's where our answer belongs. So if we focus on this block, which is negative, our answer is what we have up here. So it's x less than -2. And then the second answer, where is it? Is here where we have the negative, of which is x greater than what? Greater than 1. So that's how we get to the answer. We can't be able to get to this answer without using a table. We don't do a guesswork in this case, so we must use a table. It also have a mark. Is the table method okay with you?
Yes, sir.
All right, wonderful. I'm very happy that you can understand the table method. So, but it will be important for me to also do the graph method, because the graph method, you also use it to interpret the functions. There are questions where you will need to find the value of x where the product of the two functions is greater or less than 0. So you must be able to interpret the graph in such kind of instances. Hence, I will have to do the graph method on this question. So the graph methods need us to expand this first. So we are having 1 minus x and x plus 2. So we must expand that first with an inequality. We multiply 1 with x, we're going to get x. 1 with 2, we're going to have plus 2. And the negative x with x is negative x squared. And the negative x with 2 is negative 2x, which is less than 0. We add the like terms if we have, so it means we're going to have negative x squared, negative x, and then plus 2 is less than 0. Why? On a graph method, we need to multiply this first. We wanted to get the sign of this coefficient of x squared. So if it is negative, it means the graph, it faces downwards like this. If we had a positive coefficient of x squared, the graph was going to face what? It was going to face upwards. Is that clear?
Yes, sir.
All right. And then from there, we use the critical points we obtained here. So the smallest critical point, we write it here. So it's -2. And the highest critical point, we write it there. So it's 1. Now we interpret the graph. So this is how we interpret the graph. If the graph is below the x-axis, it means that part is negative. Like here, from here going to this side, our graph is negative. But from here up to 1, the graph is positive. Why is positive? Because it's above the what? It's above the x-axis, right?
Yes.
And then from here going to this direction, the graph is negative again. So that's how we interpret the graph. Whenever we come across a situation where we need to interpret the graph, you just have to rely on the x-axis, because it's the one which tells us if the graph is negative or positive within a region. So it will be negative if it is below the x-axis, like here going to this direction and here going to this direction. But it's positive from here going to that direction, because this part is above the x-axis. So now the question will be, what are we looking for? We are looking for a portion where the graph is what? Is negative. The question again could be, where is that portion where the graph is negative? Is from here going to this direction. So in other words, it's from here going to that direction, right?
Hmm.
And again, is from here going to that direction. So we must be able to write this in an expression form. So it means it's going to be from x less than -2, and again from x greater than what? Greater than 1. And that's how we arrive to the solutions, which must be exactly the same as the solutions we obtained by the table method. Is that clear?
Yes, sir.
Wonderful. So if you understand these two methods, then you must be fine with regard to how you deal with inequality questions, because that is the only trick you will come across. Especially here on the table method, you must be able to interpret these values, and again on the graph method, you must be able to interpret the graph, and this, it will help you to deal with questions under the function again, because we're going to do a lot of interpretation under a function. I will do revision on functions after we finish everything, so that you see what I'm talking about. Okay, then now let's go straight to the next questions. So you can see I'm doing a lot of explanation. I want to make sure what we discussed today, you don't forget even a single thing. So this is the next question. Next question is simultaneous, I think. Let me verify. Am I not jumping anything here? All on 2020 question paper. All right, this is the next question here. The time moves very fast. Here is the next question, which they like to bring. It looks difficult, but it's very simple. We are required to solve for x on this question here. So how do we solve for x on that question? Is it 18 there? Yes, it's 18. Whenever you see a square root, whenever, I'm emphasizing this, whenever you see a square root, this is the square root here, you must know that we are going to square both sides. No ways. There is no any other approach we deal with these questions. Whenever you see a square root, you must know somewhere down there, we are going to square both sides because this square root must die. We can't factorize or we can't solve for x having a square root, so it must die. And to make sure that the square root is no longer there, we must square both sides. So there are situations where we don't have to jump with squaring both sides. For example, instead of having this equation in this form, let's take this -2 to the other side. We will be having root of x plus 18 and then plus 2 equal to x. On this kind of situation, we don't have to rush in squaring both sides. The first thing we do is to make sure that on the other side, of which in this case could be on the left-hand side, we are only left with what? With the expression under the root. That's the very first thing we must do. We make sure what is on the left-hand side is in terms of the root only. That's when we can be able to square both sides. Otherwise, in this situation, we can see this 2 is not under the what? It's not under the root. So we can't square both sides like this. So otherwise, if we square both sides, we will be complicating the question. We need to take this 2 to the other side, and then it will become like this expression that is given there. So if everything on the left-hand side is under the root, that's when you can be able to square both sides. So we can square both sides like this. We will be having that expression wherein the root and squared can cancel each other. We'll be left with x plus 18. And then on the other side, we expand this. There's an approach which is very simple of expanding that, wherein this you must give it that squared there. And then the middle term, you multiply these 3 numbers here, it will give you a middle term. So it's x times -2 times 2. That will be 4x. It gives you a middle term. And then this is -2 times -2, which will give you a +4, like that. Then you take this to the other side, you're going to have x squared. When you take x to the side, it's going to give you -5x. You take this 18 to the other side, it's going to give you -14, and then equal to 0, because it's 4 minus 18, which is -14. From there, the next thing may be to factorize this. Sometimes it may not be factorizable. If it is not factorizable, we use a quadratic formula. But if it is factorizable, we must factorize. And the factorization of this, let's check which one is going to work for this. The numbers which when we multiply, we get 14, and when we subtract, we get 5. It's 7 and 2, because 7 times 2 is 14. 7 minus 2 is 5. Therefore, these are the correct ones. And then the signs. So the signs we need to check here. If it is negative, it means one of these must be negative. If it is negative here, it means one of these must be negative. And then again, we check this sign here. If it is negative here, it means negative must be on the bigger number, of which in this case, it must be on the 7. And then the other one must be positive, like that. So therefore, it means on the first one, we're going to have x minus 7 equal to 0, or x plus 2 equal to 0. Then it means x will be equal to 7,
or x is equal to -2.
Are we together on that one?
Yes, sir.
Wonderful. So that is how we deal with that question. Time is running so fast. Do you know how to deal with simultaneous equation?
Yes, I do.
Wonderful. That's good news. We must be able to deal with simultaneous equation. So is this kind of situation wherein the simplest equation, it must be equation number 1. And then you must make one of these disable the formula. You choose the one which, when you make disable the formula, you don't have a fraction. Fortunately, in this case, you can choose whichever. If you choose x to be disable the formula, you are not going to have a fraction. If you choose y disable the formula, you are not going to have a fraction. Therefore, this question is not a problem. It's very simple to deal with. So otherwise, the complicated part can be to simplify that. Otherwise, it's a very simple question. All right, let's go straight to the last question, which say, if n is the largest integer for which n to the power 200 is less than 5 to the power 300. Is that so? Yeah. If n is the largest integer for which n is to the power n to the power 200 is less than 5 to the power 500. Determine the value of n. So this is just a matter of balancing. So we know 5 to the power 300 is something which you cannot be able to do on your calculator. It will give you an error if you press it on your calculator. 5 to the power is a very big number. It cannot be, even though it's equal to something, but you cannot see it in this calculator we have here. So we must have a strategy to deal with this kind of situation. So, and the strategy is for making sure that the what do we call the exponents are the same. So once the exponents are the same, then we can distribute the value of n. So we can be able to tell which value of n is going to be in that case. So we assume a situation wherein the exponents are the same, of which here are not the same. You can see we have 200 there and we have a 300 there. So it means we can't say n is less than 5. Why? Because exponents are not the same. We make sure exponents are the same and then we'll discuss about the denominators. Why am I saying that? I'm using this principle. We say if x is having an exponent of 3 and then on the other side we have 5 to the power exponent of 3. What can we say? Because we have same exponents, then we can equate the what? We can equate the base. We're going to have x equal to 5, of which is the similar situation wherein we are having, let me say we have 5 to the power of x equal to 5 to the power of 3. We can use the same principle wherein if bases are the same, what do? We equate the exponents, right?
Yes.
So in this case, it would be x equal to 3. So we can use similar approach to deal with this question, where we have to make sure the exponents are the same. If exponents are the same, then we can deal with the basis, like what I've done in this situation. So let's approach this question in that way. So, but it would be a tricky situation to arrive to that answer. There's a very simplest method we can use in order to deal with this scenario. So we can have to multiply both sides. So it's n to the power 200. We multiply with 1 over 200 like this. And then what we have done on the left-hand side, we must also do on the right-hand side. On the left-hand side, we multiply by 1 over 200. So it means even on this other side, we must multiply by what? By 1 over 200. So that will be n. 200 and 200 cancels each other. So it's n less than 5 to the power of 300 times 1 over 200. So the zeros, they're going to cancel each other, and you have 5 to the power of 3 over 2, of which that you can be able to press into your calculator. What is 5 to the power of 3 over 2? That will give you 11. Therefore, n must be less than what? Must be less than 11 for this to be equal to. So n must be 11 here for this inequality to hold. Is that clear?
Okay. Okay.
Yes.
Why is she applying 1 over 200?
Reason you multiply 1 over 200. Is it on this question? Our main goal is to make this n the subject of the formula.
Yes.
And the problem we have is this exponent here. So we must find a strategy of killing this exponent of 200, of which the strategy for killing the 200 can be to multiply both sides by 1 over 200. Because if we multiply by 1 over 200, the 200 on the denominator will cancel with the 200 on the numerator.
Okay.
Yes, so that's why we take advantage of this. We take advantage of this so that this 200 here cancel with this 200, and we're left with n that we are looking for.
Okay.
Yes. All right. I was able to answer all questions under a 2020 question paper. I'm going to give you a homework. The homework, I'll send it immediately after my class that is coming now, because I don't want to point to the question paper for a particular reason. So I'm going to send the question paper immediately after this class, and then you will do it as a homework.
Okay.
All right. Otherwise, for today, let's stop here and enjoy the rest of the night.
Okay, bye.
Bye.